Hi everyone, in this lecture we are going to discuss the last topic in module 5, which is related to statical determinacy. In this lecture we are going to learn what kind of constraints that we need to impose to a structures, okay, such that that structure is stable and determinate. Okay, in this lecture over here we will talk about two-dimensional systems, and I will strongly encourage you to read the textbook discussions and lecture note related to these topics and how is it applied to three-dimensional system, for example. Okay, and then let's get started. Okay, so our goal in this lecture is to learn what kind of constraints that we need to impose to a structure in two-dimensional plane such that that structure is stable. Okay, and we have learned in previous lectures that for structures, or for example a beam located in a two-dimensional plane, there are three rigid body motions, right? Vertical motion, right? And if this is the plane, then there's a horizontal motion, and also there's a rotation. Okay, so there are three rigid body motions related to structures located in two-dimensional plane. Okay, so let's say that right now we have this beam, right, located in two-dimensional plane. Okay, my questions to you: what type of constraint that I need to include in my beam such that the beam are stable? Okay, in other words, what type of constraint of reaction support that I have to put to my beam such that those reactions can prohibit the rigid body motion of that beam. Okay, well, we have learned different types of support reactions in this module as well, right? The first type of reactions, for example, we have a pin, right? We have a roller, right? And we have a fixed support. So let's say that in here I'm just trying an error. I will pick the pin support and put it at this end of the beam. Okay, and let's say that I put it at end A. Okay, and let's call this end over here is end B. Okay, so when I put a pin at point A right here, okay, what kind of rigid body motions that I have restricted? Well, the answer is a vertical and horizontal motion, right? So when I put pin at A, right, when I put pin support at A, I restrict the rigid body translation, right? It is both in the vertical and horizontal. Okay, so for example, right now I put a pin right there, right? And this is the pin. I put it right here. You can see that right now when I'm trying to move this beam up and vertically and horizontally, it cannot move anymore, right? Because this pin is holding up, right? However, there's still one rigid body motion that hasn't been restricted by this pin, which is the rotation. You can see that this body is still able to rotate in this two-dimensional plane right here, right? Okay, so my questions next is what type of support that you need to put to these beams such that the rotational rigid body motion is restricted. Well, some of you may answer that, how about if we put a roller? Yeah, that's a good idea. Okay, so when you put a roller, right, basically we have something in here and then a roller in here, right? So right now, because when we have a pin, it cannot translate horizontally anymore, and it also cannot translate vertically. When we put another roller in here, it's basically hold this beam intact, stable in a two-dimensional plane, okay, such that all of the rigid body motions right now are being restricted. Okay, so afterward, right, when I put a roller support at B, okay, I constrain the rotational rigid body motion, okay. And when we try to draw the reaction forces in here, at A we have 1, 2, right, AY and AX, and at B we have BY, okay. So in here we have 3 unknowns, right, and we know that in a two-dimensional plane, two-dimensional systems, we can write 3 equilibrium equations, right, which is sum of the forces in the x equal to 0, right, sum of the forces in the y equal to 0, and sum of the moment at any point equal to 0, right. Then we have 3 unknowns, we can write 3 equations, then everything in here should be solvable, right. It should be we should be able to calculate all of these reaction forces. These systems is what we call as a stable system, right. This system is what we call as a stable system, right, because we have constrained all of the rigid body motions, right, and then it's also determinate, okay. So I repeat again, the system is what we call as a stable system because we already constrain all of the rigid body motion, right, and also we call this system as a determinate because we can apply the equilibrium equations, the static equilibrium equations, to find all of the reactional supports or unknowns, okay. Okay, and then I would like to ask you another questions right now, okay. So let's say I have another beam right here, right, okay, and then let's say that instead of putting pin and rotor at A and B, right, so I put a fixed support at A, okay. My questions to you, is this structure stable, okay, and then is this structure determinate or not? Well, remember a fixed support, right? In a fixed support, how many reactional support we have? We have 3, right? AX, AY, and MA. This MA is really happening at A, right? I just draw it a little bit far away from A for a clarity reasoning, okay? So there are 3 reactional support, AX, AY, and MA, okay? Would this reactional support hold all of the rigid body motions of the beam? Well, if we have AY and AX, definitely it's already hold the rigid body translation, right? The vertical and horizontal motion of the beam, right? But once I have MA right there, so will it be able to hold the rotational rigid body motions? Well, the answer is yes, okay? So with these 3 reactions support, AX, AY, and MA, the structure becomes stable. The answer is yes, because like this. So this is my fixed support, okay? So when I try to apply a load in here, for example, you see that there is no rotation in here such that the entire structure of this beam cannot rotate because we already fixed it right here, okay? However, please differentiate between the rigid body motion and the deformation of the structures. So what is the difference, okay? So rigid body motion is the entire structures moving together, right? As a whole rigid body. Deformation is something like this. Even though I already fixed in here, if I apply a load in here, you can see that there's some curve in here, right? And that's what we call as a deformation, right? That's what we call as a deformation, okay? And this deformation is not a rigid body motion, so please differentiate it, okay? So the answer to this, once we have a fixed support, yes, we have a stable structures because we already constrain the vertical, horizontal motions and rigid body rotation, okay? And then, is it determinate? Well, in here we have three unknowns, right? We have three unknowns, and we know we can write three equations. Okay, we can write three equilibrium equations. Then the answer is yes. Okay, all right. And then let me put the structure a little bit different right now. So I have this beam, AB. Then I have my fixed support at A. Then let's say I put another roller at B. My questions to you is this structure stable, and then is it determinate? Okay, so it's a good start to sketch the reactional forces in here. We have AY, AX, and MA, right? And then at B we have BY, right? If with this 3 support is already stable, an addition support at B doesn't change anything, right? Then the answer is yes, it's a stable structure, right? However, is it determinate right now? Well, in here we have 4 supports, right? 4 unknowns, and we can write only 3 equilibrium equations. So the answer for this is that it's not determinate, right? It's not statically determinate. So for this case, there's another term that we usually call is what we call is an indeterminate structure. Okay. So in the indeterminate structures, we cannot just use the 3 equilibrium equations to solve for all of the unknowns. Okay. We will need an extra equations that we call as a compatibility equations. Okay. So this type of problems will not be asked in the static course. Okay. So however, you should be very careful in solving the problem in this course. So even sometimes we have 4 reactional supports. Okay, there's a skill to identify the problems, whether there's a leeway to saying those reaction supports are 0. Okay, and in later modules we will learn how to deal with that kind of problems. Okay, and then something for you to think about right now. If I have the same beam, okay, so right now I put 3 rollers to support the beams. Okay, I put 3 rollers to support the beam. My questions to you, okay, and then let's say I have force P right here. If this structure is stable, okay, is it determinate? Okay, so we will discuss these things in the class, but please give it some thoughts whether it's a stable or determinate. Okay, with that, I think it's enough for these lectures, and thank you for listening.